So I wanted to show you a little bit about the system we put together, a little simulation tool to help maybe define the parameters for, or at least define some requirements for performance. I use this Netlogo tool. It's really great. The programming is very easy. I encourage everybody else to take a look at it. But what I did here was set up the model from chapter 14 in Jamshidi, so and it matches its its required performance, which is sends out a group of robots. If one robot finds a mine, the rest of the robots show up and they disarm the mine. You'll see here the little framework I set up here. You can actually set the number of mines here. You can set the number of swarm robots that are active. Right now we'll go to 4, which is what the book starts off with. You can also set the swarm team size. So if you wanted to have if you only required 2 robots to disarm a mine, that can be set right here. You also can set the sensor on the robot's field of view and range. So the range is 2 blocks in front of the robot at 105 degrees. I did include, I'll discuss the blast radius and the trigger radius here in a second, but I did include that so that it would make the game a little more fun to watch. Yeah, one more thing to note is that the bombs are randomly placed, and this is the base robot here. You can move him independently of the other robots, but the base robot just stays motionless in the center of the field. The rest of the robots will break out from him when the game begins. So we have 4 robots. We'll start a game here. What they'll do is they'll go foraging around. They start off foraging. So when they're blue, they're foraging. When they're red, that means they found a mine. And when they're orange, this means they're following the scent to the mine. It's pretty simple when you just use 4 robots. It's very easy. But when you start using more than 4, it was obvious there were some pretty serious problems that came up in the game. So let me go ahead and put 16 robots on here. When you run the game with 16 robots, you'll see that the robots find mines all over the place, and when they go into the scent following mode, they have to get around or avoid obstacles of other mines that have not been found yet. You see here they're blowing up because they're not smart enough to really get around the mines, and that obviously drove a whole new way of thinking about this. Is that it wasn't so much the overall system of systems swarm robots. It was, hey, how do we manage avoiding obstacles in the game without blowing the system up, and how do we manage avoiding the obstacle of each other around the mine itself? So I worked on that a little bit, and I'll show you some stuff I added here. Another quick thing to note is that, let me restart this, is when a robot finds a mine, it communicates back to the base robot that I found a mine. Then the base robot is the one that actually finds other robots that are foraging and sends them to the mine that's been found. You can see the base robot change colors here whenever somebody finds a mine. That means that the communication is actually happening between the two agents. All right, so when the robots are actually foraging and they found a mine, and there's a lot of robots in the process of following the scent, like I said, it becomes a real problem with extra mines in between the foraging motion to the actual mine to be disarmed. So right now you can see they kind of wiggle as they approach the mine. These are really basic, it's a very basic obstacle detection algorithm. So I added a pretty advanced one, which is fairly advanced for this. And it seems to do a much better job. You can actually see the robots going around the other mines here. The orange lines are the foraging, of course, and they'll shape around the mines. It's not perfect, I still lose some guys, but in general, this will get you through this will actually solve the minefield problem. There he is right there. You can see him going around the mines, trying to find his leader's mine. So anyway, that was pretty exciting because now we started thinking about, well, what else could you do here? Maybe we could do some even more complicated obstacle detection algorithms, or even find other ways to solve this problem outside of the way that Jamshidi showed it. So to summarize this a little bit, the models seem to help us get an idea of what's important to the system or to the simulation, which would be, hey, it looks like to me right now there's a lot of things that we're not considering. One of those, the big one, is obstacle avoidance, obstacle detection, and how we manage that through the system. Do we stop and do we identify the new mine that we found on the way to the next mine, or do we just identify it? Do we blow it up? You could, I don't know how you do this right now, but we're just thinking about that. We were developing some requirements around that. Also, some other ideas came up, which would be things like using the swarm robots, seeing how they're so inexpensive, as sacrificial robots. And then you could send them out through the field from the lower side of the field to the top side of the field, assuming this is the way you're trying to go, and generate a path through the field. You could have them blow the mine up, or you could have them identify the mine and mark it, and then the base robot could keep track and develop, as we did before in that last little run with the Q learner, a path through the field pretty quickly that anybody could use. Tanks, cars, humans, other robots. So anyway, hopefully that just shows you how we use this, this simulation tool to kind of help develop some performance requirements and criteria for our system of systems. Anyway, thanks guys. Bye.